My question to you is this. So when we spent a lot of time talking about genomes and DNA over the last few years, and one of the things that we've said in the past is that is to invoke the great philosopher Donald Rumsfeld, who, of course, when talking about weapons of mass destruction in the Iraq War, he talked about known unknowns and unknown unknowns and converting unknown unknowns into known unknowns.
Yeah.
Now, it is actually profound wisdom.
It is very true. Yeah.
I'm not sure it was intentional on his part, but when we talked about the Human Genome Project, that was elevating us from unknown unknowns to known unknowns. So after we'd sequenced the first human genomes, we had an idea of what we don't know.
Yeah.
What stage are we at? Do we know what we don't know yet about the brain?
Well, it depends what you mean by know. So what I'm interested in, what this is, you've gathered from the talk, is how it does it, not just what it does. So there's general agreement on the kinds of thing it does, but what I find astonishing is that we still don't know how that is what's called instantiated, how it's represented in little nervous systems. We don't understand that yet. And that, for me, I think we're still at the level of unknown unknowns. So there's something, we know it's going on, it's in there, it's not going on, it's no spookiness, including when our consciousness. I'm a profound materialist, but that's a working hypothesis. I can't prove that. That's simply where I'm at. So for me, I think the understanding the way that nervous systems are organized, simple nervous systems, and being able to manipulate them and find out how that changes the outcome, that's the route that we will begin to understand what's going on.
Do you have a sense that it is a resolution issue, or that if we start small, we start looking at Drosophila and eventually scale up from 10,000 neurons to 86 billion or whatever it is for us, that the answer will simply be in improving the resolution, or is there something conceptual that we haven't seen yet?
Oh, I think there's definitely something conceptual. I mean, I don't know what a maggot's thinking, but I hope that it's not thinking in the same way as I am. And I don't think that's simply that I've got a lot more neurons than it's this. So something is happening, something is emerging from our complexity, which enables us to do this. And no matter what arguments I might have with you about whether your dog's conscious, it probably isn't, but certainly our close relatives, apes, it would be very unusual if there was nothing in there at all like us. I mean, Darwin's argument was that there was no qualitative difference between humans and apes. Not because he thought that we were all equal, but because it was going to be a difference of degree, not of kind. And that eventually does produce a difference of kind, because apes can't talk, we can. But you would expect on good evolutionary principles that they're going to have a glimmer of what we have. And then you can, if you really want, push that down to your dog or your cat or whatever. But my view is they're probably not. But how do I know? I don't.
You're going to get some pushback from that. I can already see some dog owners bristling and wanting to leave.
Yeah, it's about the seat of consciousness, perhaps some reticular structure, and may have evolved at a similar time to the spine. And can I say anything about that? To which the short answer is no. So, Nick Lane, where's Nick? He was saying here. He was saying earlier on that, quote, who was it from? About consciousness. Luca Turin says the only thing we know about consciousness is that it's soluble in ethanol and xenon. So you get drunk, which is one of the mysterious things about anesthetics, yeah? Or going to sleep. Anesthetics are the most bizarre thing. You inhale the gas, consciousness goes away. You recover, and it comes back. I mean, there's an awful lot written about consciousness. I have one chapter on the book, and to many people's dismay, I'm not actually interested in it because I don't think it's a doable problem. So I'm a scientist. I'm interested in finding answers. And beyond noticing the mystery, I think that there's a distinct tendency for philosophizing, including by scientists. I mean, philosophers, that's fine. It's their job. But I think scientists sometimes get caught up in that. And there are some very complicated mathematical models, which I don't understand, two competing views in particular, which are finally perhaps going to end up making different predictions, and we can actually see which one of them is more wrong. But I'm not sure that I think we kind of lost our way a bit. So one of the big surprises to me in writing this book was that I knew that Francis Crick, who co-discovered the double helix, I knew that he'd gone off and studied consciousness. And I thought, okay, well, that's what old men do. I mean, he did it when he was younger than me, but, he went off and he studied consciousness, and that's the kind of thing you do. To my absolute astonishment, as I was dealing with the whole of the present, the last 50 years, in every part of the book, except that dealing with neurotransmitter, Crick was there. His influence was extraordinary on how we think about the brain, on the development of computer models of the brain, of connectomes. The only reason we're trying to work out what brains are made of, how they're wired up, is because Crick got very cross and said, we've got to know this. And one of the things that he argued is that we should be looking for the neural correlates of consciousness. Not how it all works, but just find bits of the brain that seem to do that switching off thing when we pour booze on them or anesthetic gases. That's what are processing particular visual signals. And I think we've kind of lost our way a bit in big meta models of how it all works, and it's a reductionist approach, which was Crick's raison d'etre, to try and understand the simple things first.
From a historical point of view, me and Matthew made a TV program about this from when we looked at the work of Rembrandt,
indeed. So Rembrandt, like Descartes, was convinced it was the pineal gland. So Descartes, he said, yes, that's where the soul interacts with the mind. The soul interacts with the brain. And this is a unique structure to humans, he claimed. So everybody went off and they dug about in virtually every other animal, and they found, they've all got pineal glands as well. So there've been an awful lot of claims for this is the place where it all happens. Maybe it doesn't happen in a place. Maybe it is distributed. And this kind of mixture of localization and then discovering that things are distributed and in different parts of the brain is one of the themes of the last 150 years, really.
And the beauty of anatomy is available on the iPlayer currently.
It's very good, very good.
Episode 3.
Mary Beard was saying how marvellous it was, I remember, on Twitter.
Oh, that's nice. Yeah. I didn't know that. Thanks. Right, another question. Gentleman there had his hand up first.
I guess the only, my only answer to that is one of faith, confidence in science. That is, yes, just as we will understand it in the end. Can I prove that? No, it could be that is so, in particular, the human brain and the emergence of consciousness is so mind-bogglingly complicated that we'll never get to the end of it. Now, I'm confident it's not going to happen in my lifetime or in the lifetime of my children. This is a centuries task, but I'm confident that the only way we have got a chance of finding it out is science and our brains. Even if we end up using computers and setting them en route to try and work it out, and maybe then it will pop up in them too. I don't know. I doubt that myself, but there's obviously a strong argument amongst some philosophers and even scientists that will be the case. So I don't have an answer to your question. What was striking in reading the book was that repeatedly over the centuries, there have been periods at which everybody suddenly panicked and thought, we're never going to figure this out. And there's been a sudden return of mystical ideas and now it's all about panpsychism. You probably read about this, that there's loads of people think that everything's consciousness, rocks, my clockwork, the only reason my clockwork ladybird knows not to fall off is that it's conscious as well. And serious people are arguing this. Now, I think this is complete nonsense, and it's a failure of confidence in the scientific method. But I haven't got any better argument than that.
It's the sort of God of the gaps argument,
yeah,
isn't it?
Absolutely.
If we don't have an answer, then it must be something that we haven't conceived of yet. And in fact, that's one of the things that Daniel Dennett writes about and criticizes, the invention of the concept of qualia.
Yeah. So this is what is it to feel that something is, say, a berry is red? That's this qualia, this quality, this strange emotion sense that we have. It's very indefinable. But I'm not interested in philosophy. The word qualia isn't mentioned in there, I don't think.
Quite
maybe
right
just
too.
once.
And in 30 years' time, we will only think about it in historical terms. Next question, please. So this lady here.
Well, the most extraordinary thing I saw last week. So that's part of the problem with brain science, they don't stop. It's even worse than ancient DNA, which Adam got very cross with. People keep on finding things out. And this didn't make it into the book, but it can make it into the talk. So I said earlier on, I'm using one of the lateralized features of the human brain. That is the left side of the brain. So there is this young woman who's about to go to university who had a complete lobotomy. So literally half of her brain was removed when she was incredibly young in order to prevent her from getting terrible epilepsy. Now, she does absolutely fine on that. She's absolutely fine. She probably, if you did some tests on her, she'd have some problems in not being able to see things in the right-hand side of her visual field because they took away the left-hand side of the brain. And yet, she's about to go to university. She can speak. She can do all of those things that we thought were only possible with the left-hand side of the brain, and the plasticity in ways that we cannot imagine. I think she had the operation when she was about 3 or 4. That's enabled her to be able to speak using the right-hand side of her brain. So there are possibilities, especially when you're young, extraordinary possibilities of plasticity. And similarly, there are various people who've recovered from what should be completely debilitating strokes who are now walking around. And these are very unusual, so they get written up with kind of, one subject did this. So it's not normal, but it can happen. And I think that I don't really know how to explain that apart from saying that, the brain is organizing itself, but I'm not really sure that really helps us very much beyond saying it's plastic. It's got this possibility of changing if it's at a very young age or if you're very lucky.
And that's a relatively new concept as well. In textbooks, when I was an undergraduate, it would say unequivocally that the brain stops developing new neurons, stops making new connections by the time children are about 5. And that was in the 90s.
Yeah.
And now we just don't think that.
Yeah.
Okay. Now, you, sir, you had a hand up for a while.
Again, this is something quite extraordinary that I have no idea about. The amount of things that, I did a psychology degree, so that was when psychology was basically neuroscience plus a load of Freud in the 70s, but it also enabled me, where I was in Sheffield, to go on to study Drosophila, so it was a very strange kind of subject back then. And despite having, grown up with a lot of this stuff and thought about it for a long time, I still discovered some amazing things. So, for example, in the early 1950s, they're, again, trying to work out, in particular patients, how they perceive, to stop them from having terrible epileptic fits. And to prepare them for that, you have to open their skulls, and then you give them very gentle electrical stimulation. And if you see the signs of a fit beginning, then you know this is the part of the brain you need to remove. So this is relatively crude, but it's still changing people's lives. And what a Canadian researcher discovered was that he's probing the hippocampus, and he discovers that people would say, oh, I can hear my Auntie Jenny singing a song. And then they would start singing along with this song, this popular song from the 1920s. So a song that was absolutely no significance that she'd heard 30 years earlier, and it was being replayed. And there were loads of examples. Oh, I can see my mum telling my brother off he's put his coat on the wrong way round. Just random crap. None of it was of any significance. It wasn't, oh, I remember, when I first saw the love of my life, or anything important. It was just nonsense that was sitting in these people's brains that you could recover by probing with an electrode. Now, you couldn't do this consistently, from one subject to another, but there were regions that did seem to be associated with hearing different bits of music. And what's happening, we don't think that it is the hippocampus, these structures in your brain here, you've got 2 of them. That's not where memory is, but that's the key that you use to get in. It's probably, again, distributed in all sorts of ways around the brain. But you can record this get subjects to replay it effectively. So it does suggest, a bit like those awful Google glasses that people were wearing and got beaten up for because they were recording everything, that in some bits of our lives are just being put away, stored away all the time, and that maybe we can, I mean, some of it you might want to get out, some of it you wouldn't want to. It's very, very strange.
So much of our understanding of, well, certainly in the 19th and 20th centuries, understanding of psychology and neuroscience was born of people who had very traumatic brain injuries. And from that, we extrapolated quite macro understanding of the anatomy of the brain and its relationship to behaviour. Does any of that, such as this girl you're talking about who's now going to university with a full half and
brain.
bottom, can we relate any of that sort of macro anatomy to the molecular understanding of thought or those sorts of processes?
I think the answer to that is no. Are you trying to lead me on?
No, it's a genuine question. It's a genuine question.
No, I think, so the molecular level, I mean, part of the, I haven't mentioned this at all, but you all know about the mental health crisis, right? So we've got all this work on maggots and on computers and all the rest of it. And yet we have a terrible crisis of mental health where we don't understand the basic biology or psychology, whichever you prefer, at any level, of how and why we have mental health problems. We know it's real, but we can't precisely deal with it. And the main way we have of dealing with it through chemicals, this has been the big discovery of the last kind of 40 or 50 years. I mean, the reality is that if you take these serotonin reuptake inhibitors, which are the main things you give them, say, for depression, we don't actually know that if you're depressed, you've got low serotonin levels. We don't know if you take the pills, if that increases your serotonin. We don't know anything about it, how it works. That having been said, if any of you are taking those pills, please don't stop taking them without talking to your medic, right? Because if it works, fantastic. They work for some people, but everybody knows they don't work for everybody. So we've got this huge gap in our knowledge. And what's striking is that all of the major drug companies, all of them have abandoned this area of work. None of them are developing any more drugs to deal with the things we all know are significant: depression, anxiety, and so on. So they don't think there's any money in it because they can't see how they could do it. So they rode a wave of luck in the 1950s and 1960s, and now they're basically jumping ship. And there's nothing more coming down. The pipeline's empty. Nicholas Rose, who's a sociologist of medicine, said very dramatically in a book last year, there's nothing coming down. So we've got this real problem. We know this stuff, but putting it into real human terms, what really counts for many people, we don't have the foggiest idea. And any of you who've had family members or yourself had mental health problems will probably know that. I encountered that in talking to psychiatrists and realized that they didn't have the foggiest idea. They were doing the best they can, don't get me wrong, but it's tremendously difficult.
We're still in a very clumsy brute force type area with regards to this.
I think we are the equivalent. I'd mentioned Galen's influence on medicine. I think we're in a Galenic period. We don't, the big breakthrough in medicine was the germ theory in the 1820s or 1830s, and they realized what was causing disease, and then eventually that led to antiseptics and changes and all the rest of it. I think we're pre-germ theory in understanding how the mind works. I really don't know. I mean, I've learned, given that I'm a doctor of maggots, right? I may have read Freud, but that wasn't much use. I really don't know, and I'm not sure we could probably come up with some general model about how things are amplified, and this is partly what talking therapy can be very useful for trying to put things into their relevant place. And we can deal with this, things like phobias. We can cope with phobias, right? So if you're freaked out by spiders, then you can very easily end up with tarantulas running all over you simply by desensitizing yourself and bringing them safely closer and closer to you. Realize that there's no reason to be frightened of a tarantula, and then eventually you can have it walking on you. And that works. So phobias we can deal with, but the deeper things like anxiety and depression, I'm not sure we have any real understanding of what's going on.
3 most important words in science are?
We don't know.
Okay, question from the cheap seats up there.
Very good. So what can we learn by studying creatures which don't have brains? Well, their lobster's stomach is kind of that. I think and seriously, I mean, so one of the, these very simple things like Platinaris, there's another very larval aquatic organism that we have the complete connectome of, I think you're going to be able to work out how very simple networks can produce sometimes quite complicated behaviors. This may go down to the molecular level. So if you think of single-cell organisms, they don't have brains, but they can respond to movement, they can learn, they can associate stimuli, they change their behavior depending on repetitive stimulation. So maybe we can get at more molecular ways by studying single cells, paramecium, and maybe things that aren't even animals. But the key point is, so Warren McCulloch, the chap with the big beard, he wrote an article which said, why is the brain in the head? And I thought, God, this is going to be interesting. And his answer was, well, that's where all the neurons are, which isn't really much of a help. But I think he's got a point there. So the brain is, why is it in your head? Yeah? So the brain appears when you get what's called bilateral symmetry. So I'm bilaterally symmetrical that way. But I'm not bilaterally symmetrical that way. I'm asymmetrical. I've got a head at the front and I've got my bum at the bottom. And those are the two most important things. You've got your mouth and your bum and your brain. And your brain is putting all those sensory organs together so you can either find prey, if you're a predator, or avoid a predator if you are going to be eaten. So there's a reason for that. And in terms of what the brain did in its very earliest stages. And to mention genetics and evolution, we still don't understand. We still don't know if my brain, or yours, and the brain of those maggots are the same thing. We don't know if they're homologous. So did the common ancestor of a maggot and Adam, did that have a brain? Or was it just some kind of networky bag of things that was just a load of neurons? Did it have a head? Did it have a brain? That we don't know the answer to yet.
And what about the other end of that question? What about studying organisms such as the octopus, which has a very different brain structure, distributed brain? We talk about having 3 separate brains and independent movement in its arms or legs. What are they?
Yeah,
legs?
Arms. Not the tentacles. Yeah, so they're not that different. And so people go, yeah, man, they're alien. They're not, they're just clever slugs, It's just, people don't get excited about slugs, but you could do the same kind of thing. They're just mollusks. That having been said, they are clearly very smart, and is one of the great things about the UK, that the animal rights legislation, the animal protection legislation, experimentation, which is largely due to people taking out court cases against David Ferrier, in fact, that the legislation in the UK protects both all vertebrates and now it's been extended to all cephalopods, so squid and octopuses, because we know that they are clearly a lot smarter than your average maggot, and therefore they need to be very much protected. I'm not sure that, they're very exciting, and there's a fantastic book about the mind of the octopus by
Peter Godfrey Smith.
Him. And that's a brilliant book called Other Minds.
Other Minds, yeah.
Yeah, absolutely marvelous book. But I'm not sure, whilst it gives us great insight, I'm not sure extending yet another really complicated thing is going to help us. At the moment, we can turn neurons on and off in a mouse brain. We can make a mouse remember something it's never seen. We can get a good mouse memory and turn it into a bad one, and vice versa. So we can do most astonishing things with mice brains. And the latest thing I managed to just slip it in, is they were able to basically recreate the memory activity of the mouse, take it from one mouse and recreate that in another mouse, and that mouse had learned the same thing, showed exactly the same behavior. So we're getting very, very close to be able to, getting quite close to understanding the real nature of these phenomena. But I think then starting off with something, you've got to do it in water and it's very, very slippy. Let's stick with the mice, stick with what we've got.
Mm-hmm. Okay, I reckon we've got time for 2 quick questions, and I'm sorry, I'm giving you a very left-handed bias here, because I'm facing in this direction.
This gentleman over here, so I'm standing in the way.
This lady here first, and then this gentleman has been waiting, so there's be the last 2.
Yeah, I was very aware of this, so, Western bias. Now, the problem is, science is largely a Western product. in terms of the apparatus of science. And most of the people I've been talking about, and you will probably have noticed, they were all blokes, apart from Eve Marder. So the people who've done science have been one particular group. In terms of, so I deliberately, especially in the early chapter, wanted to find out, well, what other people thought about this, the heart and the brain? So that business with the words is dead easy in English, but I don't know, what about other cultures around the world? And it turns out to be the case that virtually everybody thought it was the heart. So if you look in the Bible or in the Quran, it's great now, you can search it instantly. The word brain is not mentioned in either book. It's all about the heart. The heart is where God seems to have his thoughts and where humans have theirs in both books. And one of the most striking things is Carl Jung, the psychoanalyst. He went to New Mexico in the 1920s, and he discussed with one of the Pueblo Indians there about their beliefs. And this Indian chief said, well, we think the white people are crazy. We think you're all mad and horrible and evil. And so Jung was taken aback by that. I'm not sure why, but he was taken back, and he said, well, why is it? And he said, but you all think with your brains. And Jung said to him, well, where do you think you think? He said, we think here. So this is an idea that's been everywhere in all cultures as far as I was able to determine. In the 19th century, anthropologists went and talked to people all up and down the Americas, indigenous peoples, and recorded their views. And whilst we don't know that they're kind of pre-colonial views, it seems pretty likely. There's one exception to this, which I realized at the last minute as I was trying to find this out. I suddenly realized, wait a minute, what about Australia? What about the Aboriginal peoples? And that was really, really hard to find out. And the reason was quite clear in the end. I talked to various Aboriginal researchers and got a big book of encyclopedia of Aboriginal beliefs. And the word brain is not mentioned. And I talked to somebody and they said, well, yeah, but that's because it doesn't make any sense to us. The idea that we'd localize thought, even in our heart or in our liver, as some people's thought, because of their connection with the land. So self and thinking is not simply in the body, it's actually connected to the land and to deep time. In other words, they've got a completely different way of thinking about how and where thought emerges. Well, as I kind of indicated, we're a bit stuck because there's this argument which seems very simple. We should be able to know, is the brain, are all brains homologous? Are they the same thing? But there is, in fact, a huge row between different branches of evolutionary developmental biology and people trying to say that it is or it isn't the same. In terms of what its original role and its role in most animals, then the kind of definition I've given there about representing the outside world and enabling the predictions to be made, I think is generally accepted, even in something very, very simple like a maggot. So there, even with something like C. elegans, which doesn't really have a brain at all, it's got whatever, it's 302 neurons and about 60 kind of neurons gathered together at the front end. It seems if you immobilize them, you get the same patterns of activity in the brain as when they're wriggling around. So it's almost like they're thinking of moving. I mean, I don't know whether that's the right way to imagine it, but we know brains do similar things in all animals, whether there's a deep homology or whether they have the same structures. So, for example, the wiring diagram in your nose and in the maggot's nose is basically the same. We don't know whether that's convergent evolution. Evolution's found the same solution to the problem of detecting smells, or whether our common ancestor had a brain that looked like that. And that debate is still out. But the homology in the primate lineage, so us and our relatives, that was something that Darwin worked on and was able to actually show, as I say, this very, very similar structures in all our close relatives, which made him increasingly convinced of our animal origins.
Okay, we're out of time. That was stupendous. Yeah, just masterful. Matthew's going to be out the front,
Yep.
Just out there with books. You can't shake his hand, but he will sign.
I will do this.
He will sign books to you. I can't recommend this book enough. If it's half as good as that as a lecture, then it's well worth your money and
feel
your time.
Feel free to look at this, but don't nick it, because it was expensive.
17 quid.
17 quid on Amazon. Crikey.
Ladies and gentlemen, Matthew
Thank you very
Cobb.
much. Okay, now this way.